So in this video, I just want us to look into OSPF and create a backup of OSPF routing protocol. So whenever OSPF fails, the backup route entry will be used. So I'll just need, let's say just need 2 routers in this case to save time. Just need 2 routers to save time. And in fact, I think as per now, we need to start applying the best practice of using IP addresses, uh, because we did subnetting sometimes back, so we don't need to use /24 every now and then, because /24 tells us that there are 254 usable IP addresses. So if we use here to be, when we put here to be 254 and there are only 2 usable IP addresses, meaning we're going to waste a lot of IP addresses. So concerning subnetting, a link with 2, an area with 2 usable IP addresses should take /30 notation. So let me just assign them IP addresses very fast. Turn it on, and /30 notation is always 1. So /30 notation is always 255.255.252. That's according to subnetting. /30 notation.
252 because repeat that again. Why?
Yes. /30 notation. So /30 notation is equivalent to 30 bits. In IPv4 address we have 32 bits, and for a full IPv4 a full subnet mask for IPv4 address is 255.255.255.255, which is a broadcast address. Now /30 notation is equivalent to 252, I mean. So how do we convert how do we know how do we convert the / notation to a subnet mask? So for example, here you see /30, you can see here is 254. So for example, if you have /24 here, you can see it's 255.255.255.0 all /24. Yeah. So if you have /32, which I was saying that a full IPv4 address has 32 bits, so it's 255 all the way. So it's very, very important when we are using when you see it's a point-to-point link, you don't need to waste IP addresses. And you see it's a point-to-point link, you don't need to waste IP address, because it only needs 2 usable IP addresses. That's why I use /30 notation. So /30 notation, the first IP address here will be 10.10.10.1, then the second one will be 10.10.10.2. So .3 will be broadcast. Yeah, so we don't need, there are only 2 usable IP addresses. Okay, so I'll do it very, very fast. Then if I go to the other one, this one is now just now 192.168.1.0. Sorry, 192.168.1.1. Okay, so I configure this also. Copy. One dot let's say 10, and the default gateway is that one 1.1. I go here also 20 default gateway. Let's say it was 1.1. 8.1.1. Okay, so we go this side. If this one was 10.10.10.1, this one should be 10.10.10.2. So I go there and go to 10 gig 00, turn it on first, then 10.10.10.2. And the subnet mask, because it's starting notation, will be 55.255.252. And we go to gig 11, which should be 192.168.2.1. Copy that. All right. So to the PCs, let's say 2.10. Then this one is 2.30 or 2.20 maybe. 2.20. So a quick recap about what dynamic IP, or I mean what dynamic routing or just routing in general means. In this topology here, this router here, by default, a router only knows about the directly connected networks. So this router 0 here only knows this network and this network, the directly connected networks. The same applies to this router 1, this network and this network. The router 1 here doesn't know that this network exists, this one. The same way router 0 here doesn't know that this network exists. So it's upon us, because if they don't know that these networks exists, meaning any device in this network will not be able to communicate with the devices on this side. The same applies this side. They will not be able to communicate this side. So that's why we have to implement a routing protocol to tell them the paths that they should follow, to tell this router that please tell your neighbor your status, and this neighbor here please tell the other neighbor your status, so that the PCs on the right can know that, or this router here can know that there is another network in the topology which is not connected to it. Also, this router 0 will know that there is another network in topology that is not directly connected to it, although it's connected to my friend router 1. So it's very, very important to understand the concept of routing. So there are several types of routing and we've done them. So in this video, we're going to configure OSPF. Okay.
Hello?
You done?
Yeah, no, go ahead. Yeah, I just declined the call.
Okay, no problem. So I was saying that in this video we're going to configure OSPF. Remember in the previous videos we configured the RIP and EIGRP. So in this video it's OSPF. We're going to use OSPF as the routing protocol to advertise networks on this side and on this side also. And we have added something here, backup static routing. So let's assume that OSPF suddenly fails. So what will help us? We have to use a floating or backup static route. So it's very important to use that one in any network. So I'm just going to start configuring OSPF. The first step, as I have done, make sure that you have configured IP addresses to the interfaces and verify that you did the right thing. Then let's proceed. The first step also, then at the second step, as I have said, you make this router aware that it's using OSPF as the routing protocol. So you just say router OSPF. Then, for the case of OSPF, there is something that is called process ID. So it's very important to include the process ID. In my case, let me use 10. You can use any number. Make sure it can be even from 1 to 100 or 1 to 30 because I normally use 10. So router SPF 10, you make the router that it's using process ID, I mean a routing protocol of SPF with a process ID of 10. Then you give the router an ID. This is a process ID, but now you give it an ID. An ID is just like an identity. So routers can know that my neighbor has this ID. So it's for easy identification. So just say router ID to be, let's give it 1.1.1.1. It should be 4 octet, just like an IP address. But in this case, we normally give them these numbers from, let's say 1.1.1, 2.2.2, 3.2.3.3. But it's not a must to give it. It's not limited to that. You can specify your own. But we normally give them this one to differentiate them from the normal IP address that we use. So you can just say this is 1.1.1.1 and hit enter. After making the router that is using OSPF with a process ID of 10 and giving it a router ID for easy identification, like a tag name, like your name, everybody has a name. So if you go to you go in a club, you're being called, you know, you have your name and someone can call you with that name. So router ID. Now let's advertise the networks here. So this router here wants to tell anyone in the network that I have this network, I have this one. So it's like the router is shouting to everyone so that they can hear it. So you just advertise the networks 192.168.1.0. You only advertise the networks that are directly connected to it. This router, this network, and this network. So with subnet mask 255.255.255.0. Then, as we said earlier, in OSPF, there's a concept of areas. So as per now, we will be using area 0. You can use area 1, 2, 3, 4, 5. But area 0 must be present in any network because area 0 is the backbone area. So in every network that we're going to configure, you have to include area 0. Area 0. And you hit enter. That's the first network. Let me now advertise the second network. Before that, let me just finish on this router first. The second network is I'll try to let me just do it again. The second network is 10.10.10.0 with the subnet mask of /30 notation. We say that /30 notation should be 255.255.255.252 area 0, and you hit enter. So exit and do right. So what I wanted to say, when we are configuring OSPF and EIGRP, we normally use what is called wildcard mask. But even the normal wildcard mask is an inverse of subnet mask. So inverse of subnet mask is what is called wildcard mask. But in this case, we have used just a normal subnet mask. So how will we know the wildcard mask? The first thing that we do, I'll open Notepad. After opening Notepad, I'll just tell you this: do show start. You can see here, I have configured OSPF here with a process ID of 1.1.2, process ID of 10, a router ID of 1.1.1, and a network of 192.168.1.1, 1.0. Then we are finding a figure that we never configured here, 0.0.0.255. Also, we are finding a figure that we didn't configure here. So I'm trying to tell you that when you are configuring OSPF, try to use wildcard mask. I came up with this concept first because I just want you to know what subnet wildcard mask is. So this is what is called wildcard mask. Wildcard mask is the inverse of subnet mask. So if subnet mask is 255.255.255.0, then let's say this is subnet mask. Now wildcard mask WM will be the inverse of this. How do you calculate the inverse? Very simple. You take the full subnet mask, which is also the full 32-bit mask, 255.255.255 minus this. You minus this. Copy and I paste here. So it's like let me just drop it down here. Okay, so you minus here. So how do you identify wildcard mask? You take the full subnet mask. In any scenario, just take the full subnet mask and the subnet mask in question. In this case, the subnet mask in question represent this subnet mask /24 notation. We want to identify a wildcard mask of /24 notation so that we can configure OSPF here. So let's assume we didn't write this. So we want to identify wildcard mask here. How do we do it? We minus here. Now we take 255 here minus 255 here will be 0. So it's 0 dot. Then this one minus 0. Then here also dot 0.
0.
Then 255 minus 0 is 255. So that's how we calculate wildcard mask. So in this case also, if I go down here, you will see this. It's here with its wildcard mask. So let's calculate the wildcard mask of the second scenario, which was 2552. The normal, the subnet mask in question is that one. So I try to paste it here and take this, copy, and I paste there. So how do we just take this one? This one is 0. Then 2555, that's 0 also. Then 255, that's 0. Then 2555 minus 252 is 3. So that's the wildcard mask of this one. It's just inverse of subnet mask. Very, very simple. And that's what we'll be using to configure OSPF as per now. We are not going to use the full subnet mask like this one. We have to use wildcard mask, because even if you use this one, you can see it's changed automatically to wildcard mask. So we have to do it the professional way. Okay, so we have managed to configure OSPF on that router. So let's go to this router here. Before I go to this router, I'll try to ping. Remember, we have configured this OSPF here, but we have not configured OSPF here. Meaning, they have not become friends. They speak different languages. They speak OSPF, they speak nothing. It doesn't have any routing protocol, so they cannot become friends and share their status with each other. So let me try to ping. This is 2.20. So I'll try to ping 2.20. Ping 102.168.2.20. You see, destination host unreachable. It cannot ping. Why? Because we've not configured OSPF here. So let's do it here. Enable configure T. So the first step, just make the router aware that it's using OSPF as the routing protocol with the process ID of 10. Make sure at this level, make sure that you configure similar um, parameters on these two routers. If you're using a process ID of 10 on this side, make sure you configure process ID on this side also as 10 at this level. Then now give it an ID or name tag identification. So just say router ID to be 2.2.2.2. You can give it any number. Make sure it's 4 octets. And give it a number that is that can be easily identified. 2.2.
These 2 you just select the number.
Yeah, just randomly choose it for route ID and make sure it's a 4 octet. Make sure it's 4 octet, and also make sure that it's totally different from the IP address that you're using. So for example, in this router here is connected to this network and this network. So your router ID should not be similar to these two. Okay, yeah. So that's why people normally use route ID as 1.1.1, 2.2.2, 3.3.3, or 1.1.22, or 3.3.22, something like that. Okay. So after that one, making the router aware that it's using OSPF with the process ID of 10, and giving the router an ID for easy identification. So let's advertise the networks. The networks that are here, network 1 is 192.168.2.0. Now, what's the subnetwork of this one?
What? Yeah, I got you.
Yeah, on this side now. The subnet mask is /24 notation. /24 notation is equivalent to 255.255.255.0. So you don't use that one because we are trying to adopt all the best design principles or the best design practices. We now want to use wildcard mask. So wildcard mask of /24 notation is equivalent to 0.0.0.255 as we calculated here. So just minus it from the full subnet mask. Okay.
Yeah.
And then you give it an area 0.
Area 0.
Yeah. Make sure that you always give them area 0 as per now. Another network is 10.10.10.0 with the wildcard mask of this is a slash notation of 30. Slash notation of 30 is equivalent to 255.255.252. So if you minus that one from the a full bit 32 full bit subnet mask, you'll get this value here 0.0.0.3. That's a wildcard mask. So 0.0.0.3 area 0. Don't forget area. Exit. Do right.
Slow down. Okay, yeah.
Yeah. You get it now?
Like the 0.3. I mean, 0 areas. You got that from 255 minus 25.
This
525.
you use
Yeah.
this was the subnet mask. But now we
Oh, yeah.
want to use wildcard mask. So wildcard mask is the inverse of subnet mask. So how do we get the inverse mask? Well, wildcard mask, I mean, it's a full subnet mask minus the subnet mask in question. Remember, our subnet mask in question is this one. Transport orientation is equivalent to this one. So,
Okay.
yeah. So that's how we get it. So after doing that, you can see we've received a message here. OSPF adjacency with the process ID of this one, neighbor. You can see the neighbor is 1.1.1, which was this router. This router was 1.1.1. Yeah, so they have become friends. So they are now friends, and communication can now be possible between these two networks. So if I try to ping again, just give it some time, it will ping, because we've let each and every one of these routers to know the status of each other. You can see it's now pinging. Actually, I want to let you know that it's very simple to configure these routing protocols. Very simple. Yeah. So it's very simple to configure these routing protocols. Just few lines and you're done. So only these few lines and we're just done with the configuration. So I believe you understand what OSPF does in the network.
So, okay. I don't know. We only do for those like routers PF10, we have to define the router ID, and for the network,
Yeah.
there is those how I know how to get those area.
Yeah.
I mean, how do you call, is this area like what you call 0.00000.25525? What is that, subnet, right?
Wildcard. We call them wildcard mask. Wildcard.
Wildcard mask.
Wild. Something
Oh,
wild.
wow.
Yeah. Wild.
Okay. Uh-huh. So,
WILD.
okay, yeah, that was a challenging question. What does OSPF do? Like, why do we use OSPF?
Okay. Like I said previously, that this router only knows about this network and this network.
The neighboring
Yeah,
network.
the directly connected, not the neighboring, the directly connected networks.
Oh,
Yeah,
uh-huh.
yeah. So if you use FPF,
Mm-hmm.
it will let this router know that there are
Mm-hmm.
other networks in the topology that are not connected to them.
Yeah.
And it will tell this router that if you want to go to that network, you have to use this
Mm-hmm.
router.
Okay.
Yeah.
Gotcha.
Yeah. So the first thing that OSPF does is to make sure that this router is aware of the neighbors. So it builds neighbors, it builds friends. After building
Mm,
friends, it tells this router that there's other networks in the topology that is not connected to you. So I'm telling
mm,
you that there are other friends around the world that you don't know, okay?
mm,
That you don't have their contacts. And
mm,
to contact them, you have to go to this station.
mm.
Yeah. So that's what SPF does.
Okay.
Yeah. So it's just similar to the previous routing protocol that we did. It's only that there are different it's different protocols, but they do the similar function.
Oh,
Yeah.
so that means like this OSPF is the reason for this is the same as for the static for default.
Yes, but now it depends on the topology that we want to implement.
Yeah. So in on my question is, do we apply all those three or four at the same time, or if you
No.
use OSPF, you don't use static, or you can't use default? You have
Well,
to only.
it depends on the topology. In these smaller topologies, we can only use one or two, but we can only use one dynamic routing protocol with one static routing protocol. For example, you can use OSPF and give a backup. So the backup must be static. So dynamic with static we can use, or we can just use dynamic alone.
Okay.
Yeah, but we can't use. Let's say we want to use two at the same time here. That one we learn later when we are doing other routing protocols which are advanced, but at not this level. So at this level, we can only use one routing protocol. If we go far, we use with a backup, and the backup is a static. So we are going to use only two, or dynamic and static. And in most of the configuration, we are going to use OSPF because OSPF is the most widely used routing protocol in the networking field because it has a lot of advantages over other routing protocols. So we supplement it with a backup. So suppose it fails, now the backup should pick up. Now it's the time to configure the backup. It's the time to configure backup static routing protocol, or the floating static routing protocol. Let's say all of a sudden OSPF fails in this network. How will these people communicate? We have to implement another routing protocol, which is backup or floating static routing protocol. How do we do that? We do that by considering what's called administrative distance. Administrative distance. So administrative distance so you can see here that administrative distance is just a number of units assigned to dynamic routes, static routes, or directly connected routes. And if I can click on this, you can see that each routing protocol has a different administrative distance. So for example, a directly connected network has only zero routing protocol. A static routing protocol has one administrative distance. Internal EIGRP has this one, 90. OSPF, which is now the protocol in question, has 110, and so on and so forth. So we've known the administrative distance of 10. So 110, of OSPF is 110. So we go back to our design. We want to design a backup. And in most cases, a routing protocol with the lowest administrative distance is the one that is used to transport data. So in this case, we don't have any other routing protocol here. We only have OSPF, meaning it will be used by default. And the administrative distance of OSPF is 110, as we've seen here. Now we want to design a backup route for OSPF. Meaning, when OSPF fails, that route should be used. And also, I've said that a routing protocol with the lowest administrative distance is the one that will be used. So to make OSPF be the primary routing protocol, then we must configure a backup static routing with the highest administrative distance. We've known that OSPF has administrative distance.
I'm back, bro. Sorry.
Oh, no problem, man. So I was saying that when we want to implement a default, a backup or a floating static route, then we should do it with the highest administrative distance. Remember, we have to do a backup for OSPF, and OSPF has administrative distance of 110. So the backup should have an administrative distance which can be 120, 130, 140, or even let's say 170, something like that, such that when OSPF fails, because a routing protocol with the lowest administrative distance is the one that will be used. So when that one fails, because it's the primary, then the backup with the highest administrative distance will be used. So in this case, we've configured OSPF. So it's a time to configure its backup. So the backup will be a static route with the highest administrative distance than that of OSPF. So we just go this way, enable, config T. So IP route, just say IP route. IP route, where do you want the packet to route? Which packets to which destination? This destination, we want to route to this destination. We just say IP route 192.168.2.0, then 255.255.255. Here we don't use this is now a static route. For static route, we don't use wildcard mask. Wildcard mask we only use for OSPF and EIGRP only. We want that any packet destined to this place should go through this interface. Let's say gig 00. We can use outgoing interface or the IP address of the next op interface. So in this case, let me just use this one. Or you can use both. You can use gig 00 or this one. But in this case, let me just use IP address of the next op IP address, which is 10.10.10.2. So any packet going to this destination, I'm telling this router that any packet going here should be forwarded to this router, to this router's IP address here. So let me tell it should be forwarded to 10.10.10.2. This is just a normal static routing. But in this case, we were not concerned about configuring static.
Slow down. I'm pressing this one. Okay. And okay. Yeah. Okay, I got you. Yeah.
So I was saying that we are now configuring a backup static route to this destination such that it can take over when OSPF fails. But we've said that OSPF has administrative distance of 110. So the backup should have a higher administrative distance. So how do we place administrative distance? You just hit space, then you give it any value, a value that is higher than the primary routing protocol. And the routing protocol in question is OSPF. OSPF has an administrative distance of 110. So this route should have an administrative distance of around, let's say, 170. And we hit enter. So this is the backup route that will be used when OSPF is dead. So just say do write and do show IP route. So currently when you say do show IP route, did you understand this place very fast?
No.
Okay.
Like the confusion is that the 10 like
okay,
the 170.
Let me explain the 10. When you want to go to the destination, when this router want to forward that packet to this network, to this destination, we're telling it forward that
No, but
packet.
we are working on that side, the router one. I think we start with the one,
Yes,
the
yes,
two.
we are working on router 1, or router 0.
Yeah,
Router 0, not
yeah.
router 1. We are working on this router here, right?
Oh, cause at 1 9 and
Yes,
okay. We are trying to but we use the network on the other side.
yes, we are telling
That's
that if you want to go here, you have to
mm.
forward data to this IP address. And this IP address is the IP address of this interface.
Okay.
Yeah, this is static routing. But now, to make it a backup, we have to give administrative distance, which is higher than the primary administrative distance, which is this one. Do you still have the confusion? I think you did it. Is what you just did in the last assignment.
Okay.
Yeah,
Yeah.
but I said that I'm going to give another assignment to make you understand about the static routing. Okay. So when I say do show routing table, IP route to show the routing table, you can see these are just initial of telling you which letter represent which as routing protocol. For example, C represent directly connected, L represent local, C directly connected, L local, then O is OSPF. You can see OSPF is O here. C is directly connected. Then L is local. So we have 3 route entry in the routing table. So you can see OSPF has been installed and is the one that is meant to go to 2 dot something, 2 dot this one. Is the one that is meant to go to this network here. So I want a scenario where OSPF will be dead. Where OSPF will be dead. So let me just go ahead to configure default, backup static route here to backup OSPF. So I'll go to the same router, enable, config T. Then we just configure a normal static route to this, a normal static route to this network. So we are telling this router here that if you want to go to this network, if you want to go to the destination is 192.168.1.0 with a 7 mask of 255.255.255.0. Then forward this. If you want to go to the destination, follow this path. Make sure you go through this one, IP address of the next op, or you can just use this one, this interface, which is gig 00. Use gig 0/0. You can use outgoing interface like I said previously, or IP address of the next op interface. So in the first case, I used IP address of the next op interface. In the second case, I'm using outgoing interface. When this router receives a packet destined to this place, it will forward it through this interface. It will go through this here. Okay, like I said, now this should be a backup. Backup means it should have a higher administrative distance, something like something more than 110, because OSPF by default has 110 as administrative distance. So let's give it even 150 and we hit enter, and that's now done. Exit, do right. All right, show IP route, show the routing table. You can see OSPF has been installed here, and we also have local route and direct connected.
I get lost, bro. Can you repeat that? I didn't understand that.
You didn't understand which part? This one.
Yeah.
Where is it? Just a minute. config. Okay, you didn't understand this one. All right. So the same way we did here on this side. Let me open it. We did on this side, telling this router do that. Whenever you receive a packet matching this destination, whenever you see any request matching this destination, then forward it to the next OP IP address in the next OP, the next how do you say it? At the next yes. So the OP IP address should be IP address of this interface because the OP of this router is this one. So it should be IP address of this interface, which is 10.10.0, 10.10.2. Then to make it a backup, you have to give it a higher administrative distance than the normal administrative distance of OSPF. Meaning it will be a backup route. So when I say do show, I mean when I display routing table, you can see OSPF is already here, that is going to 2 dot something. That's router 0, yeah. The same thing I did here. But now in this case, I told you that there are 2 ways to configure static route. You can configure for outgoing interface or IP address to the next op. So in this scenario, on router 1, I just used outgoing interface. The outgoing interface of router 1 is gig 00, which is this one. That's yeah, so outgoing interface of router 1 is gig 00. So I'm telling router 1 that if you find any packet that is matching this destination, then let it go out through this interface. We can even make it the IP address of the next op interface, which is this IP address of this one. We can do 2 ways. So you choose the one that is best suitable for you. That's why I did it 2 ways. In the other side, I did it IP address of this interface, and on this side, I did it outgoing interface. So that's how backup routes work. So whenever OSPF dies on this router and this router, this backup route will be used. So for example, if I can just try to demonstrate, I'll try to disable OSPF. I just say no router OSPF 10. Yes. So if I go to this router, also no router OSPF 10. Yes. That's just enough. Then I try to ping again. Before that, do show IP route. You can now see OSPF is not now there. OSPF is not now there. We only have static route, which is labeled by S, with the administrative distance that we configured as 170. And if I go on this route again, remember the first time we did it, OSPF was here. So I want to do it again. Show IP route. Show IP route. Do show. Just a minute. You can see OSPF is not there. It has been replaced by static. Yeah. So that's how to configure it, which is very, very simple. And if I try to ping, I'm coming. Just give me some minutes. I'm coming back. So that's how to configure default static route in any topology that you come across. So you can see the communication is just has just went through, and that's how to do it. Very, very simple. Very, very simple. So maybe if you have any question, so that I can further explain to you. But the first thing that I'm going to do, I'm going to send you an assignment on how to configure static route. Then another assignment on how to configure RIP. Then another assignment, RIP and default static route. Then another assignment on how to configure EIGRP with the static route. Then finally, OSPF with static route. And the static route should be backup. Right. So if you have any question, I can be answering, because I can see it's almost it's 7 p.m. actually, and it's telling that.
Yeah. We will be making sure to